All right, so this is section 7.3, theme of which is double angles. So this right here, where sine of 2t equals, cosine of 2t equals sine of t, there's really not much I can do to solve this at the moment. You can't divide by cosine to make it go away because it's stuck with the 2t. So it's often nice that the variables, the arguments inside each match. So it'd be nice if they were all just t's instead of 2t and a t. So we're going to try the double angle and see if it helps. There's several versions of the cosine double angle. So let's look back at those. So those are my options there. Cosine squared minus sine squared, 1 minus 2 sine squared, cosine 2 squared minus 1. And comparing that to what I have, I'm thinking the third option might be best so that I stay with, oh wait, is that right? Or am I lying?
Cosine 2t.
We have a sine there. I think we want to end up with sines on this side. Okay, so I take that back. I think we want the second option. Because then we're just working with sines. Let's try that. And again, sometimes I try one and I look at it and I said, I don't think that's a good idea. Like suppose I instead went with the first one. Cosine squared t minus sine squared t equals the sine of t. There's too many trig functions up there that aren't alike. If I bring the sine, subtract the sine to the left, I can do a little factoring, but not enough factoring to do the zero product rule. So I think that seems like a dead end. So other option, 1 minus twice the sine squared of t. This way I have it just with sines, and I should be able to do something with this. A trick we used the other day is if there's, say, squares and just one trig function, like a sine or a cosine, then we can do a little substitution, like let's say, let's let y equal the sine of t. Then I can rewrite my equation as 1 minus 2y squared equals y. And then I mentioned before, like, with factoring, sometimes if there's cosines and sines, I'll replace sines with y's and cosines with x's and see if that helps me with the factoring. So here, I think I'm going to bring things to the right side, so I'll have a positive with the y squared. So I'm going to add 2y squared to the other side. And then I'm going to subtract the 1 over the other side. And then putting those in order, I would write it as 2y squared plus y minus 1, 0. From here, I could either use the quadratic formula or I could try to factor it. Just for fun review, let's use the quadratic formula. This looks like it probably factors. So quadratic formula says if you have something like a y squared plus by plus c equals 0, then y is going to equal big old fraction, negative b, plus or minus square root of b squared, minus 4 times a times c, all inside the square root, divided by 2a. And here my a is 2, my b is 1, and my c is negative 1. So I usually like to identify those just to make sure I apply them consistently. All right, so opposite 1 plus or minus square root. 1 squared is just 1. And then minus 4 times 2. And then with that negative 1, I'm just going to go change some signs right away, SIGNs. So that's now going to be a plus. And then that's divided by 2 times 2. 4. All right, so that inside cleans up a little bit. What do we have? 4 times 2 times 1 is 8, plus 1 is 9. So I get to take the square root of 9. So I'm going to get negative 1 plus or minus 3 over 4. So square root disappeared, meaning the original would have factored. So -1 plus 3 would be 2/4. -1 minus 3 would be -4/4. So I'm getting 1/2 or -1 as the values for y. All right, so over here, now I know that y could be equal to 1/2, or y could be equal to -1. And I can back here, resubstitute. That really means the sine of t is 1/2, or the sine of t is -1. And I think those are nice. So let's see, if y is 1/2, that's one of the angles, and that should be what? Special angle. pi/6. And then the other special angle over there would be pi minus pi/6, or 5 pi/6 would be this other one. So I've got t equals pi/6, comma 5 pi/6 here. And for the other one, when is y equal to -1, that would be down here.
3 pi/2.
And so that would just be 3 pi/2. So that one only gives us one solution. And again, the original problem asked me to find values between 0 and 2 pi. So although we could measure that as -pi/2, it doesn't fit in that range there. So last step would be to whip out a calculator and see if those do appear to be the solutions of the original version. So with the original version would mean, since it's equals in the middle, I would say this would be like an f of t or f of x, and this would be a g of x. And I want to see where the two graphs meet. So let's go back to the original version of the problem. And what we should find is they meet at some nice values of t. All right, that's it for now. It's quite a workout.
Now, were you able to get the